So for a problem like number 18, the directions say find the exact value of the expressions without using a calculator. Draw a triangle. So when you have a value here like this 5/13 that's not on the unit circle, all those problems that we just did, those values are on the unit circle. We're going to have to draw a triangle. So if you get a value or fraction that's not on the unit circle, you know you have to draw a triangle. You have to figure out which quadrant to draw the triangle in. So we always start on the inside. Anytime we have a composition of functions, we start on the inside. And we go ahead and we're doing the inverse sign so we know where to restrict our range. This is positive. So we know it's going to be in the first quadrant. So that's where we draw our triangle. And notice we connect the triangle because this is where our point is on the unit circle. We connect the triangle just like we would the bow tie. Remember the bow tie? Anytime we connect it always to the x-axis. I see a lot of connecting triangles this direction. Okay, so I'm gonna do that. All right, so sine, this is opposite over hypotenuse. Okay, and this is the, or you can look at that as y over r. Now we Pythagorean theorem it, and we know this is a 5, 12, 13 triangle, but if you did Pythagorean theorem, you'd get the same answer. You'd say, 5 squared plus b squared equals 13 squared. You solve it and you end up with 12. Now that we have that value, we have the triangle. This part gave us the triangle. We'd find the cosine of this angle right here. And we have all the numbers. So all we gotta do is find the cosine. The cosine is x over r. So that's it, 12/13, done. Let's go to 24. Can I erase? 24. 24 again has a value that's not on the unit circle. Can you go down? There we go. So we go ahead, tangent, restrict, it's negative, so it's going to be in the fourth quadrant. Now, tangent is going to be y over x, so that's going to be -5/12. I know the 5 is negative because the y is going down and the x is going to the right. So that makes the 5 negative and the 12 positive. If for example, we were up here, okay, if we would we'd be going left 12 and up 5, they'd just be opposite signs. Okay. Oh, 12. Okay. So this is the same type of triangle. I noticed a lot of people when they're Pythagorean theoreming, I just made that a verb. When they're Pythagorean theoreming these problems and there's a negative value, people get confused. This -5 is the quantity squared plus 12 squared equals the radius squared. This is going to be a positive value. So that ends up being 25 plus 144 equals r squared. So that's 169. Square root of 169 is 13. There you go, 13. And the radius is always positive. So now that we have that, here's the angle. Okay, that's the angle we're working with. And we're asked to find the cosecant. Cosecant is the reciprocal of sine. So instead of it being y over r, it's going to be r over y. So that's just going to be 13 over -5. And just as a reminder, if you put a positive number over a negative number, okay, that's the same thing as if you put a negative in front of the whole thing. So I wrote it this way, equals 13 over -5, just because that's what I have, but it equals -13/5. It'd be the same value as if you had a negative value over a positive value. The value of this expression is still negative because we have a negative divided by a positive, or a positive divided by a positive with a negative in front, or a positive divided by a negative. Same thing. All right, that's good.